Saxon Algebra 1, Lesson 120, the end. This is the last lesson of the year. We made it. I'm so excited. Congratulations. You survived. You did more than survived. You thrived. You killed this class. You guys crushed it. The topic is box and whisker plots. Perhaps the most poetic lesson for the whole year. This is a statistical measure that is kind of cool. I've seen this show up on standardized tests from time to time, but this is just kind of like a little dead end. This is nothing we're going to build on or use in any kind of greater thing. It's a statistical measure that actually just helps you visualize data. Okay, so it's a visualization. Visualization. And that's kind of cool. So this is one of those lessons where John does an example and then he starts with the examples. I don't understand why he does that. Either it's an example or it's not. But we're just going to jump in with the examples. Okay. Shown are the salaries of 12 mathematics textbook editors. Oh, isn't that cute? Okay, so this is, you've got some mathematics textbooks editors. Those are the people who wrote this. And here are their salaries in thousands of dollars. So we're going to chop off a set of zeros, and this is going to date itself because these numbers are really small. And then John gives us the numbers. I'm not going to write them down as is because that's a waste of my time, and I'll show you why. So here it is, right? It's in thousands of dollars. So this is 25,000, 23,000, 35, blah, blah, blah. They don't make very much money, but that's because this is an old book, and that used to be more money than it seems like now. So we're supposed to construct a box and whisker plot of this data. So the first thing that we want to do is put the numbers in order. John has very graciously done that for us. So I'm not going to copy the disordered range of salaries. I'm going to copy them down in the order from least to greatest. And that is always the first step of the problem. If John gives you a hodgepodge, you always put it in order. So here we go. 18, 19, 21, 23, 24. I put too much space. I'm going to have to squeeze now. $31, $33, $35. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yay! I didn't forget any. Okay. So the first thing we want to do is look at the range. Okay, it goes from 35 to 18. That means it's a total of 17 points, right? Okay, so what we want to do is we want to draw a spectrum that we can fit all these points on. So what I'm going to do, what John does, I'm going to start at 10 and I'm going to go to 40. That will give me nice coverage, right? And so then let's see, 10, 20, 30, 40, right? Okay, you don't have to fill in every single little chunk yet. We can just kind of wait and see what we need. So the first thing we do, here are my steps. I plot the high and low. I'm gonna just use a little shortcut there. So the highest point is 35. That would be right there. And what we're gonna do is we're gonna draw it up above the number line a little bit. Okay, not actually on the number line. And then the low is 18, and that's, let's say, about there. Okay? The highest and the lowest. Then we want to find the median. And I meant to write the word plot first, so I'll write it now. We're going to plot the median. Okay, the median means the middle, right? It's the part of the expressway that's in the middle. So we want to look for the median value. Let's see, we have an even number of numbers, and if we have an even number, then we average the two middle. Right? If you have an odd number of data, then you just take the middle. But when you have an even number of data points, there is no middle number, so we have to average the middle. So let's see, there's 12, right? 1, 2, 3, 4, 5, 6, and 7 are going to be the middle. And if you want to double check, you can go, okay, there's 5 numbers there, and there's 5 numbers there. So those must be the middle. Well, 25 and 27, it's not too hard to find the middle, the average of that. It's going to be 26, right? So it's 25 plus 27 divided by 2, and that is 26. We can tell just by looking at it. But that's how you would do the calculation if it wasn't so obvious. So now we go to 26 and we plot the median. It's going to be, I'm going to say that's 25, so I'm going to put it right about there. Okay? Now, what we do is we find 2 more medians. There's a dog barking, someone's pressure washing. There's a lot going on here. This is one of those things that sounds really hard when I say it in words, but it's easy. We're going to plot the median of the first half of the data and the second half of the data. Okay, so let me explain that. We found the median of the whole thing. Now we're going to divide it into half. Right? So I'm chopping this in half. So now we're going to find the median of this set of data. Okay, there it is, right? We have 6 points. So it's going to be an even number. So we have to average the 2 middle. The 2 middle are 21 and 23. We can see that is really easily 22. So I'm just right here in my instructions, I'm going to write 22. That's the median of the first half of the data. And then I go to the second half of the data. 1, 2, 3, 4. So now I'm going to find the average of those 2. Well, again, it's super easy. John was so kind to us. So now I'm going to put in those 2 points on this row of points that I'm making. All right, 22, which would be about here. And the second half of the data is 30, so it's going to be right there. Now we're ready to draw. This is the fun part. Okay, what we're going to do is we're going to draw a box around the 3 medians. There's the first half median, the second half median, and the total median. Okay, we label those first quartile, third quartile, and then this one we call the median. Okay. Median means halfway. Let me just do this last part. Once you get the hang of these, you don't have to squeeze all these words in. So here's our lowest number. Here's our greatest number. That helps us visualize that. Then we see there's the very middle, and then this is the first quarter, right? It's the middle of the first half. It's kind of like a football game, right? There's the first half, and it's divided into 2 quarters. That's exactly what this is. And then we have the third quarter. What we see in this picture is that each of our quarters is pretty close in numbers. So these math book editors' salaries are pretty evenly distributed across our whole range that goes from $18,000 to $35,000, right? Because each of these segments is about the same size. If we had something like this, whoops, sorry, I should put a dot there, not a line. If we had a box and whisker plot that looked like this, we'd say, oh, there's a lot more disparity in their incomes, right? The first quarter has a much bigger range, and then this is a very small range. So just the shape of these box and whisker plots. Now you can see where they're box and whiskers because there's the box and these are the whiskers. It shows us at a glance something about the way our data is arranged. Okay. The other example, there's only 2 examples. The other example tests us in a different way. The box and whisker plot shows the scores made on the final exam by 150 students. Find the range, median, mode, and mean of the scores. Describe the distribution. So this time, John's giving us the picture and asking us to find the answer. Okay, so we look at this. I'm just going to talk it through, and I'm not going to write anything down because it's too hard for me to make both happen. So let's start with the range. The highest score is 100. The lowest score is 55. So 100 minus 55 would be 45 for the range. That's right. The median is the next one we're asked to find. It's super easy. It's 80, right? Because that dot is the middle dot of the box, and so that's the median. Okay, beautiful, 80. The mode, which is the most popular score? We don't have any way of knowing that because we don't see the individual scores, so we cannot find the mode. It's a no-brainer. I mean, it's not a no-brainer. We can't figure it out. Same for the mean. In order to find the mean, we would have to add up the individual scores and then divide by 150 because that's how many students there are. But we don't see any individual scores, so we cannot find the mean nor the mode. Range and median are clearly defined here. B, describe the distribution of the scores. Okay, what does it tell us? I'm just reading John's answer. Well, we know that 1/4 of the students show up in each one of these sections, right? That's how it's defined. We divide the scores into fourths and draw this picture. So there was more range, more variation in the lower group of scores, and the top scores are very tight, right? So it goes kind of like a wide distribution, then it's smaller. A bunch of students came in a very close one, and then a wider range and short. So a lot of students scored very well. A lot of students scored almost. And then these sections are more distributed. So it gives you a picture, it gives you an idea, but it doesn't necessarily solve every question, which is why I'm not going to test you on this topic, which is why I want you to learn it. We are going to come back to it next year and do it again, just so that it's in your brain. But this is one of those things that now mathematicians don't have to calculate by hand because they just find a good software program and dump in their test data and it generates all this information for them. So maybe you'll be the software design engineer that creates that, but most mathematicians don't have to remember these calculations. But of course that's our job, is to learn the calculations so that when somebody says range, median, mode, mean, you know exactly what those numbers represent. All right, guess what? Yahoo, we are done. This is it. Algebra 1 has been officially completed. I don't even know what to do. I was going to say throw your book up in the air, but don't destroy your book yet because we do have to get through that final. But give yourself a pat on the back. Go scream out the window. Do something to celebrate this joyous moment. I will see you again for the review, but never again will I say, welcome Saxon Algebra 1 to you. Ah, what a moment. Goodbye.